Hello everyone, this is Felix from GM Wolf. Today we are looking again at world chunks. So this is the second episode for this sort of series we're looking at. And what I want to look at today is how to change your chunks, so edit them, and also how to save them, more importantly. And well, one of the reasons why this episode is about, changing your chunks, even though that's not really the aim of this tutorial, it is mainly because I want to show how the saving system works. So before we do anything, we have to look at the loop we had before. So what we did was use for I equals 0, I is more than width, I plus plus, and below that for j equals 0, j is more than height, j plus plus. And this is how we loop through a whole buffer in order to draw our sprites. And it is quite important to look at it because we have to look at how it numbers our grid. And this is how it will order them. So instead of going from left to right and then downwards, it goes downwards and then across in this way. So this will be quite important when we look at editing our chunks in order to see where we clicked in the world. So now that we looked at that, let's look at the saving system. So if we have our saved chunks over here, what we can do is check whether our chunk already exists, whether it's already been created and saved. Now if it doesn't exist, we can generate our chunk. Now once we generated our chunk, we can quickly save it, and we end up with a buffer from that generated chunk. Now if the chunk does exist, we can simply load the chunk, and that also gives us a buffer. Now from that buffer we can get an MD5. Now what an MD5 is, it's kind of a unique identifier, a short string really, which kind of uniquely represents this buffer. Now what's important to note about the MD5 is although it's unique for each buffer, you cannot get the buffer from the MD5. Well, when I say it's unique, you could theoretically get the same MD5 from different buffers, but the probability of that happening is incredibly small. So yeah, so you get one MD5 from your buffer. And so later on in the game, you may have a modified buffer after you had, after you've played a bit, after you changed it, and from that buffer you can also get another MD5. Now you can compare those two MD5s to see if they are the same, and basically, if they are different, it means you modified your buffer. So if they are different, we can save your chunk because it's not the same one that's on disk anymore. So we have to save it again. Now if it's not different, it means we have the exact same buffer. It means we haven't changed it, or if we have changed it, we put it back like it was before. So maybe, you changed the tile and then you changed it back or something, I don't know. So you don't really need to save it anymore. And that's, some of you may have seen my my example on buffers and the world chunks on the GMC before, and that's not something I did, and you ended up with, if you had a really large world, you ended up with you saving every single buffer all the time, even when you already had it on disk, which was kind of different. So this is kind of a little upgrade. It's really easy to program as well. MD5s do all the work for you. I've seen some people trying to loop the whole buffer, etc., but again, the MD5 is probably the best way of going around doing these kind of things. For those of you who are interested in more about those MD5s, it's what is used on the internet. For example, when you download a file, along with the file you also get an MD5 to check if you downloaded the whole file, etc. So it's kind of like the standard online to check if two things are, well, online and everywhere really, to check if two things are equal to each other. So without further ado, let's jump into GameMaker and see what how we're going to add this. So first of all, I'm just going to open up, whoops, a few scripts I had in my example project over here. I'm using as a reference because I don't want to get my code wrong. Alright, so the first thing we want to do is just quickly look at how we can edit our chunks. So let's open up our chunk and add an event. Let's add the mouse, global mouse, left pressed. So there's quite a few things we need to do in here. So the first thing we need to do is determine the bounds of our chunk, the top left corner and the bottom right corner, just to check if our mouse is within within this region, because we don't want to do all the maths if we didn't actually click within the chunk. So what we're going to do is var x1 is equal to x times tile underscore size times width. So we take our x coordinate, which is in chunks, and we multiply it by the width in pixels of our chunk. So in essence, we get the top left corner of our chunk. So if we do it with the same with y, var y1 equals y times tile underscore size times height. Now we can do the same thing for x2 and y2. So var x2 is going to be equal to x1 plus the width of our, in pixels, of our chunk, which is tile size times width. And same with y2, which is going to be equal to y1 plus tile underscore size times height. Now we can check whether our mouse was within that region. So we can use a really handy function called point underscore in underscore rectangle. And as its name suggests, it checks whether the point is within the rectangle. So first you need to give the coordinates of the point you need to check, which we're going to use mouse y and mouse x. So mouse x, mouse y, and then the coordinates of your rectangle, which is going to be x1, y1, x2, y2. Now what we need to do is find the x coordinates and y coordinates in your grid inside the chunk. So we're going to call them xx and yy. So xx is equal to mouse underscore x minus x1. So this is the mouse. So this whole bit here will take away x1 from mouse x, which means we now have the coordinate of the mouse within our chunk, so relative to the top left corner of our chunk, and now we can divide it using div, divided by the tile size. Now I'm using div because it takes up the remainder, which means we don't have tile 1.2 tiles across. We only have one, for example, tile across, which is really quite useful. So we're using this the div operator, and by dividing it by tile size, we get how many tiles along it is, and we can do the exact same thing for y. So var yy is going to be equal to mouse underscore y minus y1 div tile size. Now, why am I putting tile size in brackets? I don't know. I don't actually have to. In fact, I'll take it off because it is not useful. I had that because I had some other piece of code before, which required the brackets there, but I can take them out now. So now that we have our x and y coordinates, we need to find how far along in the buffer we are. So let's load up our PowerPoint again, and let's quickly bring this bit up. So if we look at it, what we have is as we go down the y-axis, we only go up by 1, but as we go across, we go up by 10. And that's really quite important. So that means that in terms of our game, as we'll go down, so as y increases, we only go by 1, so we can have the y having a value of 1 for every 1y. But for every x, we want to go up by whatever the height is of our grid. So as you can see, it goes up by 10 every time. So let's go back to our game, and what we can do is var n is therefore equal to yy plus brackets xx times height. And this gives us what position along our buffer we are. Now, we are using buffer u8, which means this is a 1-to-1 ratio. If you were to use buffer u16 because you had more tiles or something, you would have to multiply it by how many bytes you have for each tile. Now, we're not going to do that because we're using a simple buffer u8. But I hope you see how it works. So now we have to seek the correct position. So buffer underscore seek. The buffer is chunk buffer. That's what we called it before. And now we need to go buffer seek start. And the offset of n. just calculated. And we can finally write what we want. Buffer underscore write. Our buffer is the chunk underscore buffer. The type is buffer u8 as usual. And our value is going to be 0. So whenever we click on a tile, we're going to set it to 0, which in our game is white, as you can see. So let's save it, take this off from Android to Windows, and press play. So now we have our game as usual. Just like before, it doesn't seem to save. That's because we haven't added this yet. But however, now when we click, we should be able to change the tile to being a white one. Now just to demonstrate that saving truly doesn't work at the moment, simply because we didn't write the system for it yet, which I'm just going to set this whole thing to white here, move it out until it unloads. It unloaded, go back, and as you can see, it's not there. So what we want to do is quickly quit this and start writing our saving program. So the saving is really quite simple, but remember, we want to check whether we change the chunk, etc. Nonetheless, it doesn't make too much of a difference. So let's go back to our create event of our chunk. And what we want to do, first of all, is check whether our chunk is already saved somewhere. So in order to do this, we first need to define what the file name of our chunk will be, because we're going to save each chunk as a separate file. Now, later on in the tutorial, if you are interested, so let me know in the comments for that, by the way, I could show you how to only keep it as a single file. However, for now, we're just going to keep it as separate files. It makes it easier to debug as well. So what we're going to do is say if file underscore exists. Oh, sorry, first of all, we need to find the file name. So file underscore name is going to be equal to, so let's say that our file is going to be inside a folder called chunks, and then each file will have the name chunk, and then its x position, a space, and its y position. So chunks slash chunk space plus string x plus a space character plus string y. So this will give us a name, a file path for each chunk, where the name will be chunk x y. Oh, it's x position, y position. And now we can check whether this file actually exists. So if file underscore exists, file underscore name, then we can simply load it. So chunk underscore buffer is equal to load underscore buffer. Oh, sorry, buffer load. Buffer underscore load. This is why I have a second project to open to check what I'm supposed to write. File underscore name. And now we need to get our MD5 from that buffer so that we can check later on whether it changed or not. So I'm just going to say MD5 is equal to buffer underscore MD5 chunk underscore buffer. Our offset is going to be 0, and our size is going to be the whole chunk. So buffer underscore size, or get size, is it? Get size chunk buffer. So as you can see, getting the size of a buffer is just using buffer get size, but getting the MD5 of a buffer is really quite simple. We just have one single function for it, and it does take a few arguments though. So you have the chunk buffer, obviously, which is the buffer you want to take. The offset is how far along you want to start finding the MD5 of it. Now we want the whole MD5, the whole buffer, and then how much of the buffer you want to get the MD5 from. And again, we want the whole buffer. Now I can't really think of a situation where you wouldn't need to find the entire MD5, but there probably is a few situations. So this is it for loading the buffer. Now we still want this piece of code over here where we create the buffer and generate it, but only if the file doesn't exist. So we're just going to add an else statement and encapsulate this whole thing like so. And I'm just indenting it to make it a bit clearer, like so. So now if the file doesn't exist, we're still generating the whole buffer. However, we still need to find the MD5 of it. So I'm just going to copy this over here and paste it down here after having generated the chunk with our our nested for loops. So let's press OK on that. So now we have the loading thing, but we still need to be able to save it. So we're just going to add an event, and that's going to be the destroy event. And this is when we're going to save it. And this is really quite simple. And we're just going to do if buffer underscore MD5. So again, get the MD5 of the buffer, you know, at the end once we're unloading it. 0 buffer underscore get underscore size of chunk buffer. So now we have the MD5 of our buffer. We want to check if it's not equal to MD5. So only if it changed. Do you want to save it? Buffer underscore save chunk underscore buffer file underscore name. So remember, we want to save it with the name file name. Now there is still something to do, which we should have done last time really. That is when we unload a buffer, unload a chunk, so delete it, the buffer is still in memory, and this will cause enormous memory leaks. So we need to get rid of those, and we're just going to call buffer underscore free, or buffer underscore delete, is it? Chunk buffer. This is just deleting the buffer once we don't need it anymore, because the chunk is no longer in memory, just to free up some memory. So let's press save and play, and now what we should see is, well, we should still be able to edit our chunks, but as you can see, let's look at the top left chunk. So we have some a kind of white patch over here surrounded by some green, obviously. So let's move out, unload it, come back, and it didn't save for some reason. So something's going wrong, and I'm not quite sure what. Maybe, no, here you go, it's saved. Maybe I didn't observe it properly. As you can see, I am changing my chunk like so, and when I unload it, load it back, it's the same one again. Now, for some reason, the first time it's being generated, it doesn't seem to be. Let's see. There does seem to be a bug somewhere. As you can see, this chunk down here is different every time, but as soon as I edit it... Ah, yes, we forgot something quite important, I think. Yes. Sorry about that. We forgot to save the buffer once we generated it. That was a major point in our flowchart, if we check it over here. As you can see, we are supposed to save the chunk after generating it. And there is a reason for that. And that is, if we haven't edited our chunk, it will think the MD5 is still the same. And so it's like, oh, it's already on disk, it's fine. But it's not, because we haven't saved it already. So we still need to save it. So I'm going to call buffer underscore save chunk underscore buffer, and the file name is simply file underscore name. Now let's save it, and let's press play. And yeah, so again, if you think of an algorithm, make sure you find it. Now you may have noticed, top left corner, yeah, we already have this big white chunk that we drew last time, and that's simply because the files are still there. So not only will this system allow you to keep your world the same during your game, it will also allow you to have it the same between games, so when you reload the game. Now that may be a problem. You may want to actually delete all the chunks when you start a new game. So I'll show you how to maybe create different save files, or simply clear the whole game. But as you can see, over here we have this kind of L-shaped green blob, and if you come back, it's there already, even though we didn't edit it. So remember, you have to save it once you generated your chunk. And again, we can still, you know, take it away, unload the chunk, load it back again, and it's there. Now, if you want to see your actual folders of where everything is saved, you can simply go to your app data and under your username, go to local, find the name of your project. Here it's world chunks, and then you see there's a chunk over here. a folder named chunk, because that's what we called it over here in our create event. The folder here is called chunk, and you have all your different chunks that you created. Now if you want to quickly check something else, delete the world, you can simply right click, press delete, and next time you load the game, actually I'll keep this on screen so you can see all the folders getting generated. As you can see, all the different chunks have been generated, all the visible ones, but it's not the same one anymore. And I can go there, create some more chunks, they'll appear over here inside Explorer. So this is it for this video, guys. I hope you enjoyed it, and hope you also find it useful, and if you did, please like and subscribe. It really does help. If you have any questions about, buffers, if you want me to cover anything more on world chunks, etc., please do so, and please ask them in the comments below. I will try to respond to all of them, and I'll see you guys next time for some more videos.